Jean-Baptiste Aviat dedicates to democratizing security by developing the security products of Datadog, leveraging the unique observability capabilities of the platform. Before this, JB was CTO and co-founder of Screen, a cybersecurity company providing an automated SaaS solution to protect web applications without traffic redirection or code modification. Screen was acquired by Datadog in April 2021. JB joins us for his second visit to the podcast. This time, he's going to walk us through the state of application security report that he has created via Datadog, taken data from various customer environments and anonymized it and given us a view into some very vital statistics for the world of application security. So we hope you enjoy this conversation with JB Aviat.
The Application Security Podcast is brought to you by Security Journey. Arm your developers with engaging secure coding lessons developed with input from leading application security experts. Security Journey offers responsive developer training plans that integrate with your existing AppSec testing tools to identify and address vulnerabilities in your own code. Visit securityjourney.com to try our training today.
Hey folks, welcome to another episode of the Application Security Podcast. This is Chris Romeo, CEO of Curve Ventures, and also joined by my good friend, Robert Hurlbut. Hey, Robert.
Hey, Chris. Yeah, Robert Hurlbut, and I'm a principal application security architect at Acquia, also focused on threat modeling, and really excited to take a look at this paper and just dig into it. So very exciting.
Yeah, it's super exciting to have JB Aviat with us again for his second visit to the Application Security Podcast. And we're going to talk about the state of application security, this report that the Datadog has put out. JB, great to have you back. And we don't need to hear your origin story because we already heard it once. But great to have you back on the show as well.
Thanks, Chris, Robert. Happy to be here.
Yeah, so tell us, before we even get into the details of this state of application security, give us kind of the high-level view. Like, what is this report, and even more importantly, why create this report?
Yes, so this report is based on the Datadog customers that are using the application security products and the APM products. So this application security means a lot of things, right? And you can do application security in many ways. At the source code level, maybe as a pen tester, as a web application firewall, but where we do things, the Datadog way is from within the application, but also from within your cloud environment. And so the realm of Datadog today is really the runtime. So this is where we gather insights. And those insights, they may differ dramatically from what you are used to when you work with source code or when you detect attacks with the web application firewall, whether it's AWS WAF or Cloudflare. The big difference that we have being within the runtime, within the cloud environment of our customers, is that we have a very deep context. I like to say we are full stack because we range from the application itself, whether it's Java or Node or Python, we are at this layer. But we also are at the OS layer with the Datadog agent. And we also are at the cloud level because most customers use Datadog capabilities to monitor the cloud infrastructure. And when we manage to bridge those three items of visibility, we can provide security insights that are much more precise than what you would get with only one of those items. And so this report helps describe what we see as the big trends and the big things that you can change when you leverage those three items. whether it's in terms of threat detection, vulnerability detection, and prioritization, and more generally trends on where we see the more risks across our customer base.
Yeah, one of the things that I really appreciate about tools such as Datadog is being in the runtime environment. You have access to be able to detect, did something really happen? Like when you think about SQL injection, you can scan for SQL injection using a number of different tools that are operating on the source code itself that may say, hey, you have a SQL injection here. But when I think about the level of data and information you have inside the runtime, like if you detect a SQL injection, it's a SQL injection because it just happened. Like somebody just requested that hit a particular string or a particular URL or something. And so from my perspective, that really gives a much deeper level of insight to what's really happening versus what we think could be happening just by looking at the source code.
Yes, you can think it as, okay, it's good to have the information from your SaaS at the source code level that you have SQL injections. It's good to have the information from your web application firewall that you have someone attacking you and trying to discover SQL injections. What's really hard when you have SaaS and WAF is to reconcile both. And so how do you prioritize the reaction to a threat if you don't know what's the targeted application or if you don't know what are the underlying vulnerabilities? On the other hand, if your SaaS tool reports dozens, hundreds of SQL injection vulnerabilities, then how do you pick which one you want to go ahead first? And so while we do not directly compare to SaaS or to WAF, what we can do from inside the application is telling you, okay, look, here you had an attack that is targeting an endpoint that has a SQL injection, and that SQL injection just got exploited. And we know that because we are at the application layer hooking the database driver, so we know the exact SQL query and we know where the user input goes. And so that's true for SQL injection, right? But that's also true for SSRF and a various of bunch of other vulnerabilities.
Mm-hmm. Cool. So Leah, let's jump in. Let's. I know there's a number of facts that you were able to extrapolate from all the data that you had available, and so let's jump in. Let's start talking about what you found in the report.
Sure. So let's jump to the first fact, right? So this one is about vulnerability management. So the way we detect vulnerabilities is at the runtime level. So in the case of open source software or third-party libraries, whatever you call it, what happens is that when a service instrumented with Datadog starts, it gathers the list of dependencies that are actually required by the service and sends it to Datadog. So that's widely different from what you would get from, Dependabot or something working at the CI level, at the source code level, because what we get are the vulnerabilities that are actually required by your application. So that's the first level of prioritization, right? If your test libraries are never used in your production application, which you would expect, right? Then we will not even see it. And that's good in a way because a library that is never used will never cause you a security issue, right? You cannot exploit a vulnerability into something that is never used. So that's like a first layer of prioritization. Then another layer of prioritization is to find what services matter more than others. So for instance, a service that has only a development or a staging or a pre-production environment is not as important as a production service because, well, hopefully you don't have customer data on it. If the service goes down, you will not impact your production metrics, right? You might slow down your developers, etc., but you will not impact your production, provided you have decent separation of production and lower environment. But those are reasonable assumptions. So that's one thing. If you have a critical vulnerability on a development service, well, okay, you might not want to remediate that one first. And then the other layer that we used in order to prioritize the vulnerabilities, still using the runtime context, is whether we detected attacks on that service or not. And so that's a metric that I think is very, very interesting, because if you get back, for instance, to the Log4Shell days, where everyone was rushing to patch their applications, because, Log4Shell, it was one request and bam, you can get remote code execution on a server. Then if you have like hundreds of services to remediate, well, you need to prioritize. You cannot do everything the night the vulnerability was disclosed. I say night, I'm based in Paris, but so you cannot do everything the night of the disclosure of the vulnerability. You have to prioritize. And so what would you prioritize? Well, the services that can be attacked, because that's the ones that are at risk of getting scammed by a random hacker who just wrote their script and are trying to pop shells everywhere. So if you prioritize the production services and the services that are being attacked, well, that's a great way to look at the things you should do first. So that's true for Log4Shell, but it compares in a very similar way for any other vulnerabilities. And so when we took those two dimensions, attacks and production environments, then we see that only 3% of the critical vulnerabilities remain critical. And so the way we see it is not like rocket science, not machine learning or data science. We are just using the CVSS standard. That is like the thing that tells whether vulnerability is critical or high or medium or low. And the CVSS has a part that is called the environmental score. And so the environmental score is where we say this service is not production and this service was never reached by attacks. So we are just leveraging a tiny bit of the CVSS standard in order to adjust the prioritization of those vulnerabilities.
So when I think about this, like, is this, let me kind of bounce an idea off you. Tell me if this is what this is saying or if it's not saying this. And so I think one of the big things that people are thinking about a lot in the world of AppSec is exploitability, reachability and exploitability, right? And so is this analysis telling me that only 3% of critical vulnerabilities are exploitable / reachable, or is it telling me something else?
So in that specific score, we are not taking into account exploitability as of today. It's something we are working on, and I think we'll have something in the next few months to show. So we are working on that independently from exploitability. If you take CVSS on any vulnerability, exploitability is not a part of the CVSS score. It's part of the CVSS temporal score, because there is like temporality related to exploitability. You might think that something is not exploitable, and 2 months later, well, someone comes with a trick that makes the exploitation possible. So that's a different way to look at it, right? So what we say is that, yes, reachability, because if your service never got an attack, well, given the noise of attacks on the internet, a service that never got any attack means that it's unlikely that it will get attacked the next day, right? Mm-hmm. And the other thing is the business sensitivity, because we consider that a service that is not production doesn't have a huge business sensitivity. Does that make sense, Chris? But you are absolutely
so this
right.
This is downgrading though, right? So basically you're saying that of all critical vulnerabilities, only 3% of them are actually critical. 32% of those, what people would have said were critical, are actually high. and 65% of what the initial assessment would have said they're critical, they're actually lower. They're lower priority than what would have been reported if you just used industry data sources.
Absolutely. Absolutely, that's correct.
Okay, I think I'm getting it. I'm tracking with you now. I'm getting it. So before we go any further, just people are probably thinking like, what's the size of the data set here?
Yeah,
like, is this across? Yeah, give us some context about the size of the data that you're analyzing to get to these numbers.
Yes, I cannot disclose the exact number of Datadog APM customers, but this is the
Sure.
full APM customer base that has an agent that is pretty up to date. So we're talking about thousands of organizations, and
Okay.
so you can, yes, it's largely
it's a big data set.
It's a very significant user base.
Okay. All right. I think I understand. I think I got number one. I got number one figured out now. I think we can let's keep going. Let's keep rolling.
Amazing.
Hopefully I'll get number two faster than I got number one.
I think number two is pretty simple also. So what we computed here is a service risk. So how do you define a service risk? We defined it as the severity of the most severe vulnerability on that service. So if you have a service with one critical vulnerability and 10 medium, when we think that this service has a critical risk. All right. If a service has 10 critical vulnerabilities, then we think this service has a critical severity. And so what we computed is the service risk depending on the number of dependencies that it has. And so what we see, which seems very intuitive, right? But it was great to see that, yes, the data matches our intuition. Obviously, the more dependencies you have in one service, the higher is the risk. And it's simple to explain, right? If any dependency has a likelihood of having a vulnerability, well, the most dependencies you have, the highest the likelihood to have vulnerabilities, and so the highest the likelihood to have critical vulnerabilities. And so this is exactly what we see here. So that goes into the argument of trying to minimize the attack surface of your code base, right, and of your services. And so you know that each time you add a dependency, you increase the likelihood of having a breach, of having at least a very important vulnerability on your service.
This is good because, as you said, it backs up. This is data that backs up what I would have argued for this without data. But this gives me data to say the more dependencies you add, the more the more the service risk grows, based on the number of dependencies. So this just gives me data to be able to say, and I can prove it now. It's not like my gut says the more dependencies I add, the more chances I'm going to have a critical vulnerability in a service. Now I've got data to back it up.
Absolutely. And so interestingly enough, what we discovered is that this is not true for .NET services. And so that was very, very surprising to us because, yes, intuitively you would think it is. And that's not true for .NET services. And so our assumption is that you have much less vulnerabilities that are reported within the .NET ecosystem than in any other ecosystem. And so that's a bit of a question mark to us. Is it that the .NET ecosystem is vastly safer than the others? I'm not sure. Is it that the .NET ecosystem has much less security research than the others? I don't know. The number of dependencies that you had on every .NET services was similar to what we found with their technology. So that was nice.
Robert's been trying to convince me that .NET's better for years, as long as I've known him, and you're giving him some fuel here to make his argument even better. So.
Although I will say it's an interesting.
But do you have?
I was going to say it's interesting about the .NET conclusion there that many .NET applications still pull things from other libraries, third-party libraries. But so it's just interesting, and I don't know if it's the amount of data that was collected of apps that didn't, but certainly I do know that as it said, the .NET Standard Library has certainly continued to add things that previously were only available from third-party libraries. So I see a little bit of both of that in there, but it's an interesting fact.
That's correct. Like the size of the standard library in .NET is indeed impressive. So that might explain that. But still, since you have a lot of dependencies as well, I don't know.
All right, let's see what we got for fact number 3. I feel like I understood fact number 2 much quicker. I feel like I'm getting better with each one.
Excellent. Maybe my French accent starts to to be understood.
I'm tracking with you.
So yes, the next fact is that Java services have the highest risk. So we computed the median risk per language, right? So in Java, .NET, Node, and Python. And what we saw is that in average, the Java services have the highest risk. So you can see that we don't track PHP vulnerabilities, for instance, yet, but that will be an interesting comparison. Now, here, one explanation. So to be honest, I was expecting to see Node as the most as the riskiest technology, just because the size of the ecosystem is huge, right? And you have like a philosophy of including a lot of small libraries in your Node.js applications, but still having Java first. And so just like .NET, we can make a hypothesis based on that. The first hypothesis is that, well, Java is a pretty low-level language. It's bytecode, so you have a history of some exploitation within the JVM, and you can think of OGNL, which is also a well-known vector of vulnerabilities in Java. So that might be one reason. The other one is that Java is a big enterprisey and very mature ecosystem, which may also have a lot of attention from a security standpoint, where the average enterprise using Java is probably doing much more pen test on such an ecosystem than languages that are most used in maybe less mature environments. And so that might be a very naive interpretation, but that's one that we have to explain that fact.
I mean, I think that's consistent. When I look at this chart, Java's been around the longest. Java's got the most legacy applications that are still running in the enterprise. Like, this one doesn't surprise me at all, because I think about where was the state of AppSec when Node really hit the scene? Where was the state of AppSec when Python hit the scene? We just understood things better. Java's been around as long as I've been, seems like as long as I've been working in tech, Java's been there with me. Like, there's a lot of older stuff in Java that has got to be skewing those numbers.
I like this analysis, Chris. That's actually a good one. Yes, yeah. And I don't think we wrote that down, but yeah, I'm making a mental note of that.
Yeah, and plus, related to that, and some of that .NET as well, perhaps, but certainly with Java, as you continue to update the framework, I find sometimes that some organizations I've worked with are a little bit slower on getting up to date. They might say, well, we're stable, we're going to stay here for a little bit, we're going to wait a year or two, and then we'll update. And so as a result, updates continue to be applied to the latest versions typically, and not as much backward compatibility. So certainly I can see that might impact them as well. So it's interesting to see. Absolutely. But it confirms what I've seen as well, and in my experience in the industry.
Good.
All right, we're on a roll. Let's keep going.
Yes, and so the next one on that case.
This one hurts. This hurts, yes. JB. It hurts a little bit as an AppSec professional.
Yes, I know. I know, and I agree. So yes, the fact that a lot or a significant part of organizations still have vulnerabilities that are pretty old. Yes, and so SQL injection and SSRF from I think were discovered in 97, or at least like they were mentioned on that FRAC paper around this year. And so yes, we still have 5% of the organizations that had SQL injection vulnerability triggered, and 2% which had SSRF vulnerability triggered. And we know how those vulnerabilities can be impactful to organizations. But yes, we often hear, "Oh, it's a thing of the past, or it's not happening again." Well, for SQL injections, we have a number of ways to protect against it. Still, I think we make mistakes, right? That still happens. For SSRF, on the other hand, while the protections are far from being straightforward, obviously you can just make sure that the way you handle URLs is safe, but that depends a lot on your business logic. What are you allowed to retrieve as a URL? Maybe just in terms of context, SSRF is when you handle a user input that ends up in an HTTP request performed by your application. And if you don't sanitize that well, you might end up doing HTTP requests to a server that you were not expecting to contact. And so that leads into massive breaches where you might be able to leak the cloud credentials of the application, for instance.
Were you able to trace? Like, I thought SSRF was a lot later than the 90s. Like, and maybe I just missed something. But what's the like? When are you tracing kind of the origins of SSRF?
Yes.
Back to.
So it wasn't called SSRF at that time, but it was, surprisingly enough, in the exact same FRAC paper that described SQL injections. Really? And so it was not called SSRF. It was not like as generic as what we think about today, but it was disclosed in the exact same papers. That's the same like day, right? for both. Yeah. But it's true that I think the SSRF impact grew a lot with the specifically AWS instance metadata provider, right? Where with the single SSRF you can capture all of the cloud credentials of the application, and that's when that vulnerability really again, like it's in French I would say lettre de noblesse. I'm not sure about the English way to say that, but became like a very impactful vulnerability.
This seems to match, I think, what we've also seen in the OWASP top 10. SSRF, I believe, dropped in 2017. And now in the latest 2021, injection is no longer number one, where it has been almost 20 years. So I think, it shows a good trend, but it still shows it's there, unfortunately. But I like that, the numbers certainly are matching across the industry. We're seeing this a lot less than we did before, but it's still there.
And that's a very good point, Robert. Here we don't have a timeline because the ASM product, application security product at Datadog, has been around for about a year and a half. But we don't have meaningful historical data because like our number of customers has been on a steep curve. So I'm hopeful that for the next edition of the report, we will start to show some historical data.
Very cool. Very cool. All right. What's next?
All right. So this one I love and is pretty unique to the Datadog context, right? And so to my knowledge, such a figure was never shared or even computed before. I'm happy to be corrected if you are aware of that. But what we managed to compute with our full stack observability context is that 74% of the attacks are mistargeted. So what does it mean to have a mistargeted attack? Well, anyone who looked at the logs of a web application firewall knows that, yes, you are under attack all the time, right? And so the difficulty with those things is to cut through the noise. Usually people rarely look at the logs of a web application firewall because it's just too much. What we discover is that, yes, we can tell when we bridge threat information with runtime context is that we can discover that an attack is unsuccessful. So if you have an SSRF attack that targets an application that do not perform any outside HTTP queries, or that do not use user input in the external HTTP queries, well, you are not at risk, right? Someone is attacking you, so that's a valuable information. You might want to block the IP. You might want to understand that, yes, this application is part of your attack surface. But the fact that a SSRF attack was targeting that application is not important for you. You can dismiss that. So it's something that helps really cut through the noise, saying, look, the relevant information here is that this IP is attacking you, but don't worry, like all of the attacks have been unsuccessful.
Yeah, this is an interesting one in that the mistargeted language, like I think of times I have looked in those logs to see, and the thing that I always remember seeing is there's so many PHP scanners that are looking, and I think they're hunting for WordPress, vulnerable WordPress installations, but it seems like the bulk of those, I see so many PHP related scans that are happening. And so, but it looks like the data is telling you something different in that the mistargeted language is actually a really small part of this and technology, or is that where would you call PHP a language or a technology in this bottom part of this analysis?
No, so that would be a language, absolutely.
Okay.
So the technology would be the database, the SSRF, maybe the framework. If I'm hunting for a WordPress vulnerability on an application that is using a Symfony, for instance, where you have a technology mismatch, right? But absolutely, the mistargeted language is exactly that. That's I don't know, like a log4shell attack on a node application. Well, okay, you don't care about that. And
so this tells us, though, we can conclude from this, though, that there's still a lot of just random scanning happening on the internet. Like attackers are not, certain classes of attackers are still just broad scanning, just hitting the whole internet with particular scanners, hoping to get a hit out of something. And they're playing the bulk game of, let's buy 1 million lottery tickets with the hope that we win the lottery. Like that's what they're trying to do, is buy a lot of tickets and get 1 or 2 of them to hit.
I like the analogy of the lottery ticket. Exactly. And that's, again, why we still see a lot of like log4shell scans or things that people had the time to patch, right? But that are still being attempted by attackers.
Can you?
And so
attackers are lazy. And I shouldn't say this. I'm probably going to get in trouble or something. But like in general, people that are trying to break into applications, in large part, they're trying to do it the easiest way possible. Like it's not like on The Matrix. Okay, it's not like on Hackers or Sneakers or any of the Hollywood portrayals of attackers getting into systems. Like an attacker will take the easiest way in every time. A good attacker will take the easiest way in every time. They don't have to make it dynamic or interesting. They just want to get in. And if they can broad scan the internet and use that as the vector to get into a system, they will take it 100% of the time.
I like that you broke down the paragraph above it. I don't know if you can scroll up a little bit, but in the paragraph above it, it mentions the breakdown of the 74%. It said 66% endpoints not present, 31% vulnerabilities related to databases not used by those systems, and then 3% of languages not used in the application. So, yeah, I can certainly think of if you're trying to attack, like the database there that you mentioned, or highlighting the SQL for example, SQL Server has a particular IP address that it uses to listen for requests. Oracle does the same, and so on. And so if you're trying to attack those particular IP addresses, or IPs or ports ports to send in but they don't even use SQL Server. They don't even use Oracle or whatever. I can definitely understand that. So it makes sense.
And I think the other interesting part is that, for 26% of the attacks, we cannot conclude, right? Because maybe you're attempting SQL injections on a service that has a SQL database, right? And so not always we can tell you with certainty that here you were safe. But still, being able to do it in 3/4 of the cases, we believe is a great simplification on how you would handle threats at the application level.
Cool. Let's keep going. What's number 6?
All right. Fact 6, PHP is a top target of language-specific attacks. So to your point of random scanners looking for WordPress and similar things, Chris, what we discover is that when we break down all of the attacks that we have, some of them target language-specific things. So what I would not call language-specific thing is a SSRF attack. Well, you can have SSRF in any language, a SQL injection, any language. But if you target like WordPress.php or a PHP like object deserialization, well, it's PHP targeting. Same for Java. If you target OGNL, okay, it's Java. If you target Log4Shell, okay, it's Java. And so that's how we built that breakdown. And so here, interestingly enough, yes, PHP is the vast majority of all the attacks that we detect for the attacks that are language specific.
Mm-hmm. Yeah, WordPress rules the internet. We know it. That's why the internet exists, to host WordPress
Absolutely.
Pages, WordPress sites.
And I think
all right, let's look at this last one. This last one is I scanned ahead a little bit, and it kind of it seemed like fact 7 is a bit of a hidden. I looked at this one. I went, wait, what? So I want to learn more about this one.
Sure. So people that use Datadog, they usually tag the environments, right? So you have your production environment. That's the one on which you will have the PagerDuty if something goes wrong. And you have the dev and pre-production environments. Here it's no PagerDuty. You use that to ensure that what you're about to deploy is performant and safe, etc. What we did is break down the attacks that we have per environments. And so what we found is that, so first of all, we don't know all of the environments. That's the 17, while this one is just a noun. People don't tag it or use tags that we are not able to interpret. But for everything, we understood that 11% of the attacks target non-production environments. That's your staging, your pre-production, your development environment that is actually being targeted. And so to the same point where we said, yes, vulnerabilities on non-production environments are less critical. Well, that's great. You have less rush to update. But when such an environment is attacked, well, that's still a concern, right? And so often when people map their attack surface, they are focusing on the production expectedly, because that's where you have customer data and most of the important things. But if you think that your dev and pre-prod or staging are also attacked, well, there is a huge risk, because if you go there, you might be closer to the developer, you might be closer to the CI. Not all staging environments are handling the secrets as carefully as your production, for instance. And so that's something that, yes, as a security personnel willing to protect an organization, I need to be aware of.
Yeah, it's making me think about, or making me ask the question, are attackers practicing in non-production environments?
before they launch an attack against the production. Because if I'm going after a system and I don't have any way to test it locally as an attacker, I don't have a way to model it and run my own copy of it so that I can test in quiet, in private, where no one else can see what I'm doing. The next best thing is to practice on the non-production environment before and create an attack, a complete sequence, make sure it works, and then hit the production environment one time, perform the action, and get out of town right before any other problems. So I don't know if the data is probably not going to back up that idea as to whether that's true or not, but that's just what I'm thinking about when I look at this data.
I think of a couple of things on this. One, maybe that certainly would help, right? If you found a staging server that's a publicly available and maybe not monitored as closely, it certainly can help you to practice the real attack against the production server. I think that this is also potentially a product of, unfortunately, cloud environments that we have now where we don't have anything on premise anymore. We don't have, our web servers and so forth set up. We may have pushed them all out to cloud, and depending on, how we access our staging environments versus production environments, if we're not careful in terms of managing the access and so forth, they could be still available, still out there. And so both could be available. And that may be part of this. But again, without seeing the actual data and seeing why, but that's just a hunch, is that previously we would have all that stuff hidden. It would be internal. Nobody ever gets to it except for the internal network. And only production would be available publicly. But I think now potentially all your environments are available, because the only way you're going to get there is over the internet to get to those environments, unless you have something set up to create VPNs and so forth. But even that, you may be potentially opening yourself up. So it would be interesting to sort of follow up on this and maybe dig in a little bit more. But it's an interesting statistic.
And so I guess this to your point, Robert, I think the trend of development will just make that statistics higher and higher. Again, I would love to see what happens next year to start having a trend. But if you think of all low code or no code development tooling, well, the people using those tools, they have no choice, right? But to use a similar instance to test the thing. So almost by design, the thing is publicly accessible. It might be under authentication, but it will be accessible. I'm a big fan of Netlify. And so Netlify, it's something to preview single page applications. You just plug your GitHub repo there, and it will automatically build all the pull requests and give you a custom URL that will publicly expose the next version of your single page application. So all of those tools by design build a non-production, a preview environment that is public. And so whether this environment uses the production APIs or the staging APIs is a different story, but that will become more and more true for all the parts of the system you're working with.
Mm-hmm. Yeah, and think of accounts too. In your non-production environment, you're not using the real accounts. You're using a bunch of test accounts, and so the security around those may not be as well thought out as you would for production. So it's very interesting statistic to look at.
Yep. So my big takeaway: have no staging environments and no dev environments. Put everything in production. Test in production. Right. Okay, that's not what I actually. That was a joke. That's not an actual recommendation. I think staging and dev have their place. Have their parts. They have their place in the overall application deployment scenarios. So, JB, this is excellent. Thank you for walking us through the report. We'll definitely add a link to the report in the show notes so people can go study this in more depth. I'm looking forward to the future years. I want to see how this data updates, and I want to see how things change over a period of time. Because, I feel like I spend a lot of time thinking about AppSec, but there were a few things in here that gave me stuff to think about as to kind of challenge some of my assumptions about where I thought things were in the industry now. So thanks for sharing that with us, and we look forward to talking to you some more in the future about as you continue to watch this data and are ready to report on it in the next year.
Happy to. Looking forward to it as well. Thank you so much, Chris and Robert.